Hello and welcome back to my channel. Today we are going to discuss Cambridge International AS and A level mathematics paper 5, which is probability and statistics 1, and it is from May-June 2021 and it is 9709 and the component is 51. So let's start with the question number 1. So the question number 1 is a bag contains 12 marbles, each of a different size. 8 of the marbles are red and 4 of the marbles are blue. How many different selections of 5 marbles contain at least 4 marbles of the same color? So here we can see there are total numbers. There are 12 marbles, and red there are 8 red marbles, and blue there are 4 blue marbles. According to the question, they require at least 4 marbles of same color. So first situation, it can be like all the 4 blue are there, 1 2 3 and 4, and one place, because 5 marbles we need to select, yeah, of course. So the fifth one would have to be red, and second one, all the first 4 marbles are red and one is not red, that is going to be obviously blue. And since they ask us at least 4 marbles, so at least means 5, it can be more than 4 also. So and only possibility, because there were only 4 blues, so it cannot be 5 blues, but there were 8 marbles, 8 red marbles, so it can be all of them red. So since it is a selection, first case we can see it is going to be 4 blue out of 4, so 4C4, and then 1, since it is of different size, so it is different, so it is going to be 8C1. If it is like same 8 marbles, then we can't select 1 out of 8. It's like you are selecting 1 marble. It can be any, so it is going to be only one way. But in this case, they have mentioned that they are going to be of different size, so that's why we have chosen it as 8C1. And in the second case, there is only 1 blue out of 4 and 4 red marbles out of 8, so it is 8C4. And lastly, no blue marbles, so 4C0, and all the 5 red marbles, so it is going to be this. Now we will calculate what is the value of 4C4. We know 4C4 is going to be 1 and 8C1 is 8, so it is 8. 4C1 is 4, 8C4 is 70, so it is 280. And lastly, 4C0 is 1 and 8C5, we can calculate this, 8C5 is 56, so it is 56. So it means total selection is 8 plus 280 plus 56, 8 plus 6 14, 5 1 6 8, again 14, and 2 1 3. So altogether there are 314 selection where 5 marbles contains at least 4 of same color. I hope it is clear. Let's discuss the next one. Here is the second question. A company produces a particular type of metal rod. The lengths of these rods are normally distributed with mean 25.2 cm and standard deviation 0.4 cm. A random sample of 500 of these rods is chosen. How many rods in this sample would you expect to have a length that is within 0.5 cm of the mean length? So we can take this normal distribution random variable as x. So according to this, it is normally distributed, and here it comes, the parameters are mu and sigma square, and here the mean, that is mu, it is given as 25.2, and standard deviation sigma is 0.4. So sigma square becomes 0.4 square, which is 0.16. And according to question, there are n means the total number of samples they have selected is 500, and expect how many rods we are going to expect. It means they are asking for the expectation. So expectation of x is going to be n into p, and here the p means the probability of the length within the 0.5 centimeter of the mean length. It means if we see from the graph distribution curve, so let's say this is the graph of the normal, this is the distribution curve of the normal. So if the mean is 25.2, so the 0.5 centimeter in the length of this, so it means 0.5 here, 0.5 here. So they want the probability in this range. So this value is going to be 25.2 minus 0.5, it is 24.7, and plus 0.5, it is plus minus 0.5. So the next would be 25.7, and this probability, we'll write it as probability of x greater than 24.7 and less than 25.7, which we will calculate in the standard normal distribution. So it is going to be z greater than 24.7, x minus mu is 25.2 upon sigma is 0.4, and here it would be 25.7 minus 25.2 upon 0.4, and this is going to be n is 500. Probability of 24.7 minus 25.2 is obviously it is minus 0.5 because we have got it from here. So minus 0.5 upon 0.4 less than z less than, it is 0.5 upon 0.4, or 0.5 upon 0.4 is 1.25. so this become 500 into probability of z greater than minus 1.25 and less than minus plus 1.25, and we can see it is going to be 500, and if it is in between this same value, so we can directly write it as 2 times phi of 1.25 minus 1. So we'll calculate this value with the help of the table. So here we can see for 1.25, 1.2 and 5 is here, that is 0.8944. So this is going to be 500 into 2 times 0.8944 minus 1. So we will calculate this value, 500 into this 2 into 0.8944 minus 1 is 0.7888, and we'll multiply by 500, and the value is 394.4. or we can say, since like how many rods in the sample would you expect, it means it can be we can give the value, approximate value is an integral value, so it can be 394 or 395, both are acceptable in this case. I hope it is clear. Let's discuss the next question now. So in the third question, A part, how many different arrangements are there for of the 8 letters in the word RELEASET. So they have not given any constraint, any condition, so we can directly say that it is going to be, because there are 8 letters, so it is 8 factorial, and since there are 3 E's, so they are alike, so it is 3 factorial. So we will calculate what is the 8 factorial. 8 factorial is 40320 upon 3 factorial is 6, or we could have directly given the answer, and that was 6720. That's the total arrangement. Now in the B part, how many different arrangements are there of the 8 letters in the word released, in which letter LED appears together in that order? So it is the like there is a condition LED, and we know that all the E's are alike, so we can't differentiate between them. So we can say that if we take LED together, let's say it is LED, 3 letters together, and these, which E is there, it doesn't matter because they are alike, so it can be taken in one way. This can be arranged in only one way. And now since 8 letters were there, you have combined 3 letters, so it's like 8 minus 3 and plus 1, so altogether it is 6 letters. 1 we can say it is here, 2nd, 3rd, 4th, 5th, 6th, so there are 6 places altogether, and wherever this LED will go, they will appear in the same order. So it's the question become like, how can you arrange these 6 letters in the row? So total total arrangement or different arrangement, it is going to be 6 factorial, and since after taking 1 E there are 2 E's left, so it is like 6 factorial upon 2 factorial. Yeah, and that's the answer. 6 factorial into 2 factorial. The 6 factorial is going to be 720, and divide by, so it is 720 divide by 2, it is going to be 360. So there are total 360 different arrangements in which LED appears together in that order. We are not going to multiply by 2 because L and D has to be in the like this whole thing has to be in the same order. Now in the C part, an arrangement of 8 letters in the word released is chosen at random. One arrangement is chosen at random. Find the probability that the letters A and D are not together. So it is like we need to find the probability of if they are not together. So first we will find the total number of arrangement when they are not together. So it is total arrangement A and D are not together. First we find this, and the best way is to find if they are together. It is just together, so we can combine them, A and D, as a single letter. So there were 8 letters, you combine both 2 of them as one letter, so there are 7 together left as a letter. 7 letters are there, 1 2 3 4 5 6 7. So in these 7 places you can arrange them in 7 factorial upon, there were 3 E's, so 3 factorial. And since A and D also can also change their places, because it's just they should not be together, or in this case they are going to be together, so they can change their places. So we'll multiply by 2 factorial, and now this become, I will write this thing as such because we are going to find the probability, and since we have to find the A and D are not together, so not together means total arrangement without any condition was 8 factorial upon 3 factorial, we have seen in the first part, and now it is 2 into 7 factorial upon 3 factorial. I will use little bit of numbers here. 8 factorial, we can write it as 8 into 7 factorial upon 3 factorial. We can also do directly by the calculator, nobody is going to ask. So it is here. Now we will take 7 factorial upon 3 factorial and 2 also common, so we are left with 4 minus 1, that is 3. So altogether it become 6 into 7 factorial upon 3 factorial, and 3 factorial 6 got cancelled. It is not compulsory to solve this in this way. We can directly put it in the form calculator, and hence the probability, required probability, because probability is the number of favorable upon total number. So number of favorable, we have seen it is 7 factorial, and total was 8 factorial upon 3 factorial without any condition. So it become 3 factorial goes up, 7 factorial into 3 factorial is 6 upon 8 factorial. I can write 8 into 7 factorial. These two got cancelled and we are left with 6 by 8, which is 3 by 4, or we can say it is 0.75, and that's the probability when they are not together. I hope it is clear. This is the question number 4. To gain a place at a science college, the students first have to pass a written test and then a practical test. It means they have to pass both the tests to gain a place at a science college. Now the conditions are: each student is allowed a maximum of 2 attempts at the written test. A student is only allowed a second attempt if they fail the first attempt, and no student is allowed more than 1 attempt at the practical test. So there are 2 attempts for the written but only 1 attempt for the practical test. If a student fails both the attempts at the written test, then they cannot attempt the practical test, obviously. The probability that a student will pass the written test at the first attempt is 0.8. If a student fails the first attempt at the written test, the probability that they will pass at the second attempt is 0.6. The probability that a student will pass the practical test is always 0.3. So we have all the conditions. Now first part is draw a tree diagram to represent this information showing the probabilities on the branches. That's the tree diagram, of course. So we are going to draw the situation. First one, it is going to be a written test, because if it is a written test, then only it can be a practical test, of course. So there is a first written test W, and he got some point, the student got pass or written test fail. So getting the passing the written test in the first attempt is 0.8, so the 0.8 will come here, and obviously then failing is going to be 0.2. and now once he passed the written test, he will appear for the practical test, and practical he passed, practical test he failed. So practical test probability that student will pass practical test is always 0.3, so this is going to be 0.3, and hence it has to be 0.7. so he got the position here, he lost the position here, we can see. Now we will extend the second one. If the student failed in the first one, then he will appear for the second written test. So I can write W1 here, written test second here, and he is pass, written test second, he is fail. So again, if a student fails the first attempt at the written test, the probability that he will pass the second one is 0.6. So 0.6 will come here, and this is going to be 0.4 because it has to be 1. And then If he passes the second written test, again he will appear for the practical test, and practical test pass and practical test fail. It is always 0.3, so he can pass the practical test by the probability 0.3 and fail is 0.7. And if he is failed, so any which way he is not going to get the admission, he is not going to get the place in the college here. So only these two are the cases. So anyway, we don't have to mark these, that whether he got the place in at the college or not, but that's the tree diagram. I hope it is clear. In the second part is always going to be connected, so I will solve here. B part, find the probability that a randomly chosen student will succeed in gaining a place at the college. So we have seen here he can gain the place here by passing the practical test, and he can only appear in the practical test if he has qualified the written test. So only these two possibility. So you will multiply the probability here. So it is going to be 0.8. It is like first written test pass and then practical test pass, so 0.8 into 0.3, or first written test he was failed 0.2, and then second written test his pass 0.6, multiply of course, and then he passed the practical test, it is 0.3. So it is 0.8 into 0.3 is 0.24, and here 0.2 into 6, 0.6 is 0.12 into 0.3 is 0.036. So altogether it become, this is the question solution of this, 0.6437, and here it is 0.26. That's the probability that he will make he will succeed in gaining a place at the college. C part, find the probability that a randomly chosen student passes the written test at the first attempt. Okay, given that it's a conditional probability, given that the student succeeds in gaining a place at the college. So if we write it symbolically, we can see it is going to be, we need to find the probability that he passes the first exam W1P, given that he gained the place. By the definition, this is going to be probability of W1P intersection with gaining the place. I will say G here, gaining the place, upon probability of gaining the place at the college. And in the second part we have seen, we know the probability of gaining the place at the college. It was 0.276, I guess. Yeah, it is 0.276. And W1 intersection with P, W1P intersection with gaining it, the position, it means they are going to be this branch. So intersection is 0.8 into 0.24, 0.8 into 0.2, oh sorry, 0.8 into 0.3, which is going to be 0.24 upon 0.276, and now we can directly give our answer using the calculator. 0.26 divided by 0.276, it is 0.869596 and so on. So we can write it as till 3 significant figure, it is going to be 0.870, because 5 will increase 9 and then it is going to be 70, and that's the probability. So that's it for this video. We will discuss the rest 3 questions in the next video. Till then, thank you so much.